Hello guys, so today I'm back. I'll be participating in Codeforces round 842. It's a diff 2 round of 2 hours, and yeah, I participated in yesterday's CodeChef starters as well, but that didn't go all that well. Like I was able to solve only 2 problems and got positive delta 14, but like yeah, their rating system is quite messed up. That's why I like Codeforces more. So yeah, today I'll be participating in a Codeforces round. Let's see how it goes. 1. Okay, let's go. Come on. Okay. Again, an integer k, find the largest integer x, where x is in between 1 and k, such that x factorial plus x minus 1 factorial is a multiple of k. Okay. Or determine that no such x exists. So it can be x can be k minus 1, right? So k minus 1 factorial plus k minus 2 factorial is what? Yeah. So for 3 the answer is 2. 6. I mean, really? Let's hope that, yeah. I mean, what will happen in the case of 2? So 1 and 0, okay. Yeah, I think this works. Probably not. Ah, really? Just n minus 1 was the answer? Or am I missing something? Because they are also saying for printing out minus 1. But k starts from 2. So 2 minus 1, 1 factorial plus 0 factorial is 2, which is divisible by 2. I don't know. Okay. Quick sort. You are given a permutation p of length n and a positive integer k which is less than or equals to n. In an operation, you choose k distinct elements. Okay. Remove them and then add them. Sorted in increasing order to the end of the permutation. Okay. For example, if this k equals 2, you choose 5 and 3. Okay. Find the minimum number of operations needed to sort a permutation in increasing order. It can be proven that it is always possible to do so. So k can be anything just less than or equals to n. So it would be 0 or 1. No, it can be 2 as well. And how? Oh, because k is given to us. So I mean in each operation, Okay, so in each operation I'll have to start from the second smallest element. 3 1, so 1 2, yeah, just pick 3 and add it at the end. Now for this thing, yeah, this is a tricky one. Oh, so I can take 3 and 4 and add it at the end, right? For this case, the answer is 2. We first choose 2 and 1 and then choose 3 and 4. This way the answer will always be like n plus k minus 1 by k. Like, okay, so in the worst case that could be the answer, n plus k minus 1 by k. But in optimal cases, I think we should just check like what is the longest possible sequence of numbers that we can get from the given array. So like, can we get 1 2 3 4 and so on, consecutive sequence of elements, consecutive elements. Okay, so what I was saying is that let's say count is 1 initially, now for int I is 0, and so if v of I is equals to count, then do count plus plus, right? Now at the end just see out n minus count plus k minus 1 by k. Like, this is the number of elements, I mean n minus count is the number of elements that will be used in the operations. Somehow it is incorrect. Okay, let's see how this is right. For this case, okay, oh, so at the end the count was this, or just subtract this, I think. Don't know if it is correct, but let's give it a try. I think this is fine. Because, yeah, let's say in this case 1 3 4. Now if let's say 2 is present in between these two elements, 3 and 4, oh, this fast, nice. Elemental decompress. You are given an array A of n integers. Find two permutations p and q of length n such that maximum of pi, qi is equals to ai. We have to find both these permutations. Is equals to ai, only the maximum thing. Report that such p and q does not exist. Permutation, yeah. Both are permutations of length n. So if we think of it greedily, then I think like for this 5 I should put 4 here. No, maximum of pi comma qi, not the prefix of those elements. Okay, so the first element, let's go in for this. So in the second case, A is 5 3 4 2 5, and they are outputting 1 and 5, 3 and 2, okay. So first thing is that, yeah, like in this case, since 5 is coming two times, 5 is occurring 2 times in this array, so one time 5 has to be in the P array and the other time it has to be in the Q array, and the positions or the indexes should not be same, right? And if it is not occurring 2 times, like it cannot occur 3 times, right? It can occur either once or twice, or yeah, only, or no time. So yeah, if it is occurring 2 times, then once it should be present in the first one, other time. Okay, think I got this one. And let's just have a map, right? Okay, so let's have some flags as well, which is initially, let's say, true. Now if m of v of I is more than 2, then f is just false right away. Otherwise, I think the answer exists, right? I think so. If not f, then just see out no and just continue. Otherwise, create 2 arrays, right? If m of let's have 2 more maps, let's say pm and qm. So if m of v of I is 2, I should also create a vector that will, so yeah, let's call it absent, so these elements will not be the maximum ones in any case, or it should go from this to this. So if m of I is 0, then just push it in absent. But also if it is present once, yeah, if it is present once, then I think it's not a problem. Let's call it once. Else if m of I is 1, then call once I plus, right? I think I know what I'm doing. Now if m of v of I is 2, then if pm of v of I is greater than 0, then it's time to put it in qm, right? Qm of, or first q of I is equals to v of I and qm of v of I plus plus. Else let's put it in this thing, in p array, and call that now it is present in this one. Let's zoom out a bit. Else, oh, but there's a problem. The problem is with the element that will be put in. Okay, so I think that's also not a problem. Let's create two vectors here, absent p and absent q. Absent p, and now call absent q equals to absent p, right? And actually let's reverse it as well, or maybe I should not reverse it. The thing is, let's say 5, oh, 5 cannot be absent, right? So let's say some element, let's say 3 is occurring twice. Can 3 occur twice? Let's say 3 is occurring twice, then let's say first I am putting 3 in p, and then for q it should be a smaller element at all costs. Okay, so I think that kind of issue should not be there, and if it is there, then the answer is -1. But for that I will have to do an additional check. Let's say 3, 4 and 5 have to be present in both the arrays twice. Like 1 cannot be present twice, right? But 2 can be present twice. And all those cases we have to cover. Okay, so I think we'll have to map the values further. Twice p and twice q, I think. Else twice p not pbi and twice q dot pbi, right? So all the numbers will be in sorted order. So like all these 4 vectors are sorted now. First elements should be mapped right. But that works backwards as well. Like 5 has to be present always. 4 may or may not be possible. I think this works. Also, is it like the number of elements that have to be present? No. Oh, so the single ones can create a nuisance. The single ones can be a problem. But the twice numbers should not be a problem. Okay. So P twice. No, let's call it PQ. The other one should be QP. Print I 0, I less than I plus plus. So I think in some cases where that thing is happening, let's say 1 2 is absent and 3 4 5 are present twice. No, in that case you cannot do anything, because yeah, let's say 1 2 are absent but 3 is occurring only once. So originally I was thinking that if some number is occurring only once, then I'll just do 3 3 and 4 4 and 2 2. But I think that can be a problem in some cases. Or maybe I'm just overkilling it. But I think these maps are important. Twice P dot size. So I have to, no, asserting is wrong. This case is not a very good case, because here 1 is absent and only one element is absent. Because if I am doing this, that twice P dot size should be equals to absent P dot size, or like if it is not equals to, then see out no. I think that this can be a problem in some cases, but let's hope that it's not a problem. Twice P of phi equals to absent P of phi, right? I mean both are same, so we don't need to create two maps, I think. And these two maps also not required. Yeah, I think these two are required. Qi equals to Vi, or Qi just simply equals to PQ of Vi. And here, oh, so this was right. Instead, P of I should be equals to PQ of V of I. Here as well, Q of I is equals to PQ of V of I. Yeah, if its frequency is just 1, then P of I should be equals to V of I, and Q of I should also be equals to V of I. And in the end, just for safety measures, let's check it once more whether our answer is correct or not. Max of Pi Qi should be equals to V of I, and if it is not, then F is false. So if F, then do this. I in P I in Q else just see out now. This can fail in some cases. Let's hope it doesn't fail. Like if it is an easy problem, then this should work fine. But can it fail though? I think in this last check it can fail. Or no, let's submit it. Because the smaller element could be required in the single ones as well. If I am thinking of using the single ones in the twice ones, I don't know. Yeah, it works. Let's go for problem D. And how are we doing among our friends? Oh, top 400, not bad. Lucky permutation. In a permutation P of length n, in one operation you can choose two indices I and j, both have to be distinct, and so I have pi and pj. And the minimum number of operations needed to have exactly one inversion. Oh, exactly one inversion in the permutation. Permutation is an array. Yeah. Wait. Three, 4, 1, 2. if we are talking about only one inversion, then the last element of the array should either be the maximum element of the array or max minus 1. If it is max minus 1, then the rest of the array should be sorted in increasing order. When I'm saying sorted, then it's understood that it will be in increasing order only. And if it is maximum element, then the rest of the elements same thing applies to the rest of the elements as well, I think. No. So according to that thing, we have to restructure this whole permutation. And for that, they are taking three operations. So we can swap 1 and 3, then 1 comes to the first place. Then if we swap, then we can swap 2 and 4, and 4 will go to the 4 will go to the 4th position and 2 will be at the 2nd position. And then we are swapping 3 and 4. This is exactly what I was saying. But can there be any problem? I mean, first of all, we have to get 1 to its correct position. So if 1 is at 2nd index, then 2 has to be at the 1st index and the rest of the array has to be sorted. Right. Can we check for all such possibilities in linear time? I don't think so. Or like n log n time. Or should we sort the elements? Should we sort the whole array and then check for the answer? How is it done in this case? Just swap 1 and 4, right? So in this case only, if I'm saying that the optimal answer would look like, let's copy this. I think taking input in this case is not a big deal. We are just inputting and elements. We don't need this thing. So in this case, so the optimal cases are these: 1, 3, 2, 4, right? 1, 2, 4, 3. These are all the optimal cases, these 3. to get this array from this array, we need only one operation. For getting this array from this array, we need 1, 2 and 3 operations. For getting this array, I think for this case also we need 3 or 4 operations, but we cannot check for for all the arrays. So what I was suggesting is that let's just get the sorted array out of this given array, and for that I can swap it like this, then I can swap it like this. First swap the first and the last elements, then the last and the second element. So it took 2 operations. If I try to undo any operation, so like if I try to undo this operation, but I am swapping the second and the last element, then I am getting this array, and the number of inversions in this one is like more than 1, so it cannot match with any of these. But yeah, so the operations that I have performed is swap second and the fourth element, and swap first and last elements. So if I try to swap the first and last element in this one, then also it will not be matching with any of these. Oh, probably, yeah, so I should swap these 2 elements and then find out the number of inversions. Is this a correct thing to do? I think counting inversions is not a tough task, and it can be done in constant or probably logarithmic time only. Yeah, so I think firstly I should try to get a sorted array from the given array and store all the swap operations that I am performing, and later on check. Yeah, later on see for the answer, because this way I am like assuming that the answer would be equals to number of operations performed to sort the array plus or minus 1. This would be my answer. I don't know if it is true. Like in this case, the number of operations needed to sort the array is, okay, so first 3, 2, now just one more swap. Swapping first and third and second and fourth. Now if I try to do the same operations here, yeah, the error will not give me only one inversion. Okay, so I think if it is right, then my code should work. So it should be called misplaced, I think. If v of I is not equals to I plus 1, then misplaced of v of I plus plus. Now for int or auto element and I don't know xyz in misplaced. Also I should store the indices. Let's call it pose v of I equals to I. Old position 1 is equals to pose of LE. Old position 2 is equals to position of v of LE minus 1. Does this make any sense? Probably it does. Probably it does. Now if v of LE minus 1 is equals to this thing, then we don't have any problem. Else do misplaced of v of LE minus 1 is equals to op1. Now swap both the elements. V of op1 and v of op2. Well, it is right, or I'm messing up the indices. Also, let's create a vector of pair of ints. So v.pb op1 op2. Let me just debug this thing so that I'm sure that this much part is right. Okay, let's call it OPS. So if op1 is equals to op2, then just continue. Okay, yeah, this thing is sorted. This is the first operation. For this thing we require 2 operations, and for this thing, yeah, we do need 3 operations. 1 and 3, 2 and 4. Yeah, right. No, on this thing I think I have done something wrong. So I have 1 and 2. Nah, this operation doesn't make sense. So okay, let's see how does our misplaced map look like. But actually let's just focus on this case. Only one case. So we have 1 1, 2 1 and 4 1. Yeah, 1 should be at 0, 2 should be at 1, 4 should be at, yeah, only 3 is at the right position. So here firstly I'll check for 1, like I'll try to bring 1 to its correct position. So hold position 1 using pose of this thing. I'll get OP1, which should be OP1 and OP2. Yeah, this is right, 3 0. Then I will go for 2. Now the position of 2 has been changed. It is no longer 0. Okay. Yeah, so this is 2, V of LE minus 1. This is 2, right? One minus 1 is 0. So V of 0, OP2, this is 0. Yeah, I think this should be right. Now the operations reduced to 2 only. Yeah, I think this is correct, because we require only 2 operations. Now what? Now what? Mm. 1 0 2 0 3 1 3 0 3 1. If I undo this operation, okay, let me see the answers first. Yeah, so let's look at the 4th case first. If I undo this operation, Then sorry, not undo this one. If I undo this operation 3 and 1, then what will happen? I'll get the right answer. But now how do I check that it is the correct answer? I think this, I mean, I don't know what I'm doing, because if I undo this thing 3 0, then I am left with some stupid array. If I undo this thing, then I am left with the optimal array. I think this is just a coincidence and nothing else. Let's say we have 4 3 2 1. Then for sorting, I will have to do 1 and 4 and 2 and 3. But undoing any of these operations will not do anything. So I'll have to perform one extra operation. But this thing doesn't make sense at all, because I don't know how to get the answer from this information. Let's say somehow the answer, the number of operations were like these, and the answer won't be the thing is, if I undo this operation 3 1, I am getting the right answer. But this swap I am performing on this array, not the sorted one. Or are both the same things? No, they can't be same, right? So in this case only we have two possibilities. One is 1 3 and the other operation could be 0 and 1. Yeah, and then if I do this thing or even that thing, then I was getting the right answer. And this was the reason that made me implement this logic. How is everybody doing? Everyone has solved fourth problem, but I have no clue about it whatsoever. Or is it related to some other thing? I think the maximum that the answer can be is n minus 1 always. It cannot be more than n minus 1. That being said, cannot be more than n minus 1. If I do it reversely, one, two, and 2, 4. Yeah, I think this makes sense. If opsi.ff or min max then mx minus mn is equals to 1. Let's say initially the answer is ps dot size plus 1. Then here the answer could become ps dot answer minus 1. We can break it here. Now see out answer. I mean, this is just a pure pattern finding thing. If it works, well and good. If it doesn't, don't know. Yeah, wrong answer on second test. Do they give some additional information because of Christmas? No, they are not so. Nothing here is. So this thing is not correct, it seems like. I hope I am not messing up the implementation of what I am thinking. So in this case, yeah, in this case is good. Actually, this thing, yeah, this logic is incorrect because I'm swiping 1 and 2 and it's more of a coincidence, I think. Okay. I'm still hoping that this is the only way to get the answer. Okay. Yeah, it's kind of same, but here is a slight difference. No, let's just call it Miss V. Right, now call the reverse or Miss V. Min check on VN check to VN. Interesting. Oh, because I'm not returning anything. Yeah. In the third case, it is giving me wrong answer. Because of this case. But really? Oh. So let's create a copy each time it is gone. Yeah. Lucky permutation. And I hope my solution or my approach is also lucky. It will also fill in wrong. Ultimately, I am performing these operations. Yeah, that's the issue, that the sequence can be some other. Like there are many possible sequence of operations that can take place. Minimal number of swaps to sort an array. Is it okay, so it is an n log n thing. I think that the solution is also somehow related to this thing. it will return the number of swaps, the minimum number of swaps. Here I am getting the size of the cycle. Yeah, let's debug J. J was 0, 2, 1 and 3. Yeah. Also, this logic is absolutely laughable because max minus min equals to 1 is like this works only for 1 and 2, not for anything else. Yeah, I don't need these operations anymore. Probably it does work. Because ultimately I am just swapping 1 and 2, right? Let's see. Okay, I have a workaround. Hope it works. SMH. Right, now sort SMH. If SMH of phi is equals to SMH of phi minus 1 plus 1, then kk is equals to minus 1. Originally it is plus 1. Yeah, somehow it is working, but I'm not sure. I think it is alright to put the reference there. If I am not putting the reference there, then that might be an issue. Yeah. Really? Oh. 658, let's go. Should have solved it much earlier. Yeah, he solved it in like just 5 minutes. 9 minutes. Don't know if I'll be able to solve the 5th problem. I'm pretty sure I won't be able to solve it, but let's see. Consider a permutation P of length 3n. Each time you can do one of the following operations. Sort of first 2n elements in the increasing order. Last 2n elements. We can show that every permutation can be made sorted using. Okay. Let's call fp the minimum number of operations needed to make the permutation P sorted in increasing order. And then find the sum of fp for all 3n factorial permutations P of size 3. Since answer could be a very large outputted modulo A prime m. Unless it is some kind of a pattern recognition thing. I don't think that somebody can solve this problem. For 1 the answer is 9. Wait, what? Oh, 1 into 3. Okay. 0 times 1, 2 times 1. Oh, 1 times 0. 2 times 1, then 2 times 2, 1 times 2. So why 3n and 2n? So this permutation requires 0 such operations. This one requires only 1 operation, right? This one also. This one requires 2, right? This one also requires 2. This one requires 3. Okay. Let's say we have a permutation of length 6. For this one, we don't need any operation. But for this one, we need only one operation. Okay, so let's make this thing also very clear that yeah, we can sort only either the first 4 elements or the last 4 elements in one operation. Five, 4, 6. So yeah, I mean, let's just find out the number of operations needed to sort. I mean, how many permutations can be sorted in one operation? So it would be factorial 4 plus factorial 4. Am I right? For this thing, it was factorial 1 plus factorial. No. Because 1 is already sorted. So factorial 2 minus 1 plus factorial 2 minus 1. Yeah. So this minus 2. Perms can be sorted in one operation. So how many will require 2 operations? So 2 operations means that 2 operations means either we are performing the first operation on the prefix or we are performing the first operation on the suffix. I'm pretty sure that this was the question, right? That we can perform the operation on prefix. Yeah, first 2 and or last one. Yeah. So if we perform this operation, first or actually the order doesn't matter. Yeah, the order does matter. The order does matter. So if we are performing the first operation on the prefix, then for sure 5 or 6 or both are present in the prefix of the permutation, right? Prefix means only the first 4 elements. Okay. Let's first say that 5 is present in the prefix. Then the number of ways in which 5 can be present, or the number of permutations in which 5 is present in the prefix, could again be factorial 4, but the missing element can be either of the 4 elements. So factorial 4 times 4. Yeah, 1 for when 1 is missing, the other one is when 2 is missing, then 3 and 4. right, plus 4 factorial times 4, when instead of 5 6 is present, so just into 4 into 2. Now when both of them are present, so plus again factorial 4 times, now number of ways of choosing two numbers from this permutation, so that is 4c2. So 4c2, let's just write it like this, times times 2, because 5 and 6 can also flip. That doesn't matter because that will be included in factorial form. Yeah. Now, yeah, so these can be sorted in two operations. No. This whole thing times 2 can be sorted in two operations, I think. I think this is what I'm trying to say. Or did I miss something? Because if both of them are present there, yeah, both of them are present there, then we have a constraint. Also, even if like only one element is present, then also we have a constraint. Yeah, let's write it again. So factorial 4 is there, but one cannot go missing, right? Because we are performing the first operation on the prefix. Factorial 4 times 2 only, because only 3 or 4 can go missing. Plus same thing for 6, plus same thing for 4 factorial 4. Now the only pair remains that can go missing is 3 4. Yeah, so just factorial 4. So in these many ways the prefix can be created now into 2, because the other two numbers can also shuffle there, the suffix. And I think the same things work for suffix as well, like when we are doing the first operation on the suffix, this thing into 2. But till how long should we go? Should we keep on doing this? Here the two operations were these two only. And only one of them required 3 operations. So it can be written as 2n factorial plus 2n factorial minus 2. Yeah. And this thing times n plus 2n factorial. But this should be just 2, I think. Times 2 times 2. I think this should be n only. And if it is 1, then we have 2 plus 2, which is 4, which is not nice. So is it just, no, it cannot be n factorial. I mean, for this thing only one number can go missing from here. Oh, and also minus there can be some cases where only one operation was required, like in case of 1 2 3 5 4 6. Just sorting the suffix will do the trick, right? This is kind of irritating. No, it is like I cannot do it in 30 minutes.